Hi everyone and welcome back. In this series we're going to discuss about few fundamental principles and building blocks of object detection, and we are going to talk about object localization, and further on we'll understand the underlying principles or what you really need to know before diving into self-driving. So this area, especially object detection, so it's just exploding and it's working so much better in these couple of years with advancements of convolutional neural networks. And in this video specifically we're going to target object localization and detection. So let's start by what you're already familiar with. So previously we have already learned about image classification, and wherein you fed an image into your neural network and the output of classifier is gonna be the object present in the image. But earlier we were just detecting the image which was there in the image, but now we are gonna be dealing with a much more complex task. So in this video, this is called classification and localization, which means that you do have to label this. As in this picture, it's a picture of a car, so the algorithm is also responsible for putting the bounding box. So by bounding box I mean the boundary in which the object is located. So on the left hand side, the blue box indicates that the object has been clearly identified by your neural network, and apart from that we also have to find what type of object is present in it. So we usually label it with red or green color or whatever color you may want to use, and that's called classification and localization problem, where the term localization refers to the figuring out what and where the picture is, what the picture is all about. And we have to, when you are, even if you are trying to deploy this for production purpose, you have to be really careful of all the objects that underlie in the path of car. And classification of localization problems usually have one object, usually one big object in the middle of image that you're trying to recognize or localize. So let's deal with the terminologies. So this box is called bounding box, and classification term refers to the object which is there in the image. And when we are going to deep dive into other episodes of the series, we'll see that there may be multiple objects and we'll have to classify all of them. And localization term refers to finding where the object is located in the image. So let's say in contrast, in a detection problem there can be multiple objects, and in fact maybe even multiple objects of different categories within a single image. So the idea is that whatever you've learned about image classification, it's gonna be useful for classification and localization also, and then the idea for localization will turn out to be useful for detection as well. So what are we going to discuss in the whole series? So first of all we are going to talk about object localization, which we have discussed. Then we'll talk about detection of multiple objects. So we'll be making use of YOLO, you look only once algorithm, which came a couple of years back, and I think it's one of the most robust algorithm. There are other methods also like fast CNNs and improved version of faster CNN, in which we do segmentation and then we use convolutional implementation that we'll discuss later in this series. So let's start by talking about classification with localization by convolutional implementation. So there is an image on the left hand side, and what we do is we put it into we feeding the image into our convolutional network with multiple layers. So there's a confidence or a probability distribution generated by a neural network, and this results in a vector features that is fed to a softmax classifier, and it generates a out probability distribution indicating that how much confident our classifier is about a particular classification. So let's say if you are building a self-driving car, maybe you your object categories as they are following. You may have person, car, motorcycle, truck and background. So these are 5 classes which your classifier has to deal with. And there is also another class called background. So if no object is there in the image, or object which matters to us is not present, we're gonna just output a probability indicating that it's a background only. So and you may have to label these classes. So they have a softmax with 5 possible outputs, and this is a standard classification pipeline about how you want to localize the car in the image, as well as you can change how your neural network to have a few more output units that output a bounding box. So in particular, you can have the neural network out for 4 more numbers. So let's deal with terminologies further. So the output vector which you are going to get by softmax classifier, I'm going to call them bx, by, bh and bw, and these help us parameterize the bounding box of the detected images. So these values are going to help in indicating the dimensions and give parameters of the bounding boxes. So this is a notational convention. So the upper left of the image, if you have taken a class about Cartesian planes, you would know that we normally denote the top left corner by 0 0 and the bottom right by 1 1. And so specifying the bounding boxes, the blue rectangle requires specifying the midpoint. So that's the point bx comma by, and as well as the height bh and bw. So the training set contains not just the object class which your neural network is trying to predict, but it also contains 4 additional numbers giving the bounding box. Then you can use supervised learning to make your algorithm outputs not just the class labels, but also it will contain the parameters in the example. So the idea is that, let's say the image is the midpoint of the image is little bit left located to the middle point. So I'm gonna denote by 0.4. Then by, which is the dimension of the middle point, y coordinate, I'd say 0.5, and then the height. So height is around 0.6 and the width is 0.9, because since it contains almost all of the width of the picture. And so that's it for object detection with localization. And there's a second part of this video in which we are going to be discussing about what you really need to know about the output vector output by the softmax classifier, and how are we going to process that vector. That's called pre-processing. So don't forget to subscribe and make sure you recommend this series to other people who are really interested in self-driving. And I've created a Slack channel, so if you have any queries related to the content being discussed in this video, make sure to follow that channel, and there's an invite link in the about section of this channel. And the object detection for part 2 is coming soon. Thank you for watching this video. Talk to next one.